Okay, this is the first section, or the first section of chapter 1, lesson 4, and what we're going to be doing in here, we're going to be looking at the increasing and decreasing intervals of a graph or a function, and we're also going to be looking at the maximum and the minimum of the function. So, alright, this is taken from the book because I'm really starting to notice most of you guys are really trying to read the book, which is good, because when you go to college, guess what you're going to be doing is reading the book. So, what we're doing is we're looking at the domain interval. So, remember, domain is left to right. So, I'm looking left to right. This graph is slowly increasing, and since it's slowly increasing, then this interval is increasing from negative infinity to infinity. Okay? Alright, decreasing intervals. Again, we're looking at the domain. Domain is left to right. So, as I'm looking from negative infinity to infinity, the function is decreasing. So, on the interval of negative infinity to infinity, the graph is decreasing. If I'm looking at the interval of a constant, remember a constant is a horizontal line. So, now they put interval a to b, it should be interval from x1 to x2. So the book is actually wrong on the interval there. But from the interval of x1 to x2, it's the constant. So whatever that is, the f of x part, whatever the number it is, it could be a 3, it could be a 4, it could be a 2, but it's a, okay, the last one is the interval of a constant. The constant is a straight line. It's a horizontal line. You should have learned that from Algebra 1. There's no change. Remember, the slope doesn't change. That's why it's considered constant. Now, the book has from the interval of a to b. That's not true. The interval is from x1 to x2. So you would say the interval from x1 to x2 is a constant. So, easy. Increasing, decreasing, and constant. Up, down, straight. Okay. So, I just took this from the book because it was actually really good. So, before I even look at anything, it's basically asking, analyze the graph. Analyze g of x equals x to the third minus 3x. So, if I'm looking at it, we can say, just look at it. This is increasing. This is decreasing. This is increasing. By looking at the graph. Increasing, decreasing, increasing. So now what we have to do is we have to decide the intervals of this. Well, remember, domain, left to right. So I'm going from negative infinity to right here, which is negative 1. So what we would say is, from negative infinity to negative 1, and since I don't know if it equals it because I haven't proved it algebraically, over here, is increasing. Okay? The next thing I'm looking at is it has to continue. So I was at negative 1, and I'm going all the way to here. It's decreasing, 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 and it stops. It all of a sudden starts changing. Well, this is 1. So it is decreasing on this interval. And then if I look from this 1, it's going up and up and up, and the arrow points up, so it's going on to infinity. So this interval is increasing. So I'm okay with the increasing and decreasing, just kind of looking at the graphs. But if you need to prove it algebraically, what you do, and they have the same 3 intervals that we just put, but all you do is you start plugging in the points. Now they should have gone to negative 1. I don't know why they didn't. But you start plugging in the points, and you can see the y value, or the function value, is increasing, 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 increasing. I could have put negative 1, still increasing, but if I would have gone to the next odd number, because they went by odds, all of a sudden the number is going decreasing. So that's kind of the proving it numerically, just plugging it in. This is going from negative 1 to 1, so it's decreasing, decreasing, decreasing. It's just plugging the values in of the interval. Okay? And then 1 to infinity, 3, 5, 7, 8, they just went by, increasing, increasing. The values are increasing. So it's just plugging it in. If you can't plug in by now, then you really shouldn't be in the class anymore. Okay, so that is increasing and decreasing intervals. Okay. Now, put this, oh, I'll get that second. So now what we're going to do is we're going to talk about the relative and the absolute extremas. Well, extremas are just what we call critical points in the graph. So let me go back to the other thing. What would you say of this graph are the critical points? Well, the critical points are where it changes directions. So those are the critical points. Now, you learned these in Algebra 2, relative max and relative min. It's just what is the max, what is the min. So there's two kinds of maximums. You got your relative, and then you also have your absolute. So you got your relative max, and you have your absolute max. Again, this is taken out of the thing. So here's the graph right here. And so what is your relative max, what is your relative min? This is your relative max because it is a maximum point right here. This is your critical point because it's increasing here and it's decreasing here. So f of a is your relative max. Now, I have another maximum. Now that maximum is higher, so if that's the highest point in the entire graph, that is your absolute maximum. The same thing goes with minimums. This is your relative max, your relative minimum because it's a low point, it's a critical point. But this is your absolute minimum because that is the lowest point on the graph. Now, just a little FYI, you will not always have an absolute max and an absolute minimum. And I'll show you the one we did a second ago. This one here, that's a relative max. That's a relative min. The question is, are they absolute? Well, no, because the arrow goes up. And since the arrow goes up, that means there is values higher than the relative max. It's just, again, it's the critical point, the extremas are the critical points where the graph changes. So let's look at a problem. Oh, last one is your inflection point. All the inflection point is when all of a sudden there's like a little stall in the graph, just for like a little bit, very, very small of the interval. It's going to be the same value. Very small, but it's going to be very, very small. But that is just called your inflection point. It's, even though it's increasing here and it's increasing here, there's a little stall here. So, okay. So let's do this one. And again, I took this from the book because everyone's looking at the book right now. Estimate and classify the extremas. So extremas is relative max, relative min, absolute max, absolute min, point of inflections, the critical points of the graph. So estimate and classify the extremas of the graph. Support it numerically. All right, so if I just look at it, there's your relative max, there's your relative min. Pretty simple. If I was just to estimate it, my relative max, I could estimate it, that's about halfway in the middle, so 0.5. And it's about halfway there, so we'll say, or negative 0.5, this way. And then we'll say negative 0.5 and 0.5. That's our relative max. Now, is it an absolute max? No, because this continues. All right? Now we can say this is a minimum, so we're going to say our relative min is 1, negative 1. Now, those are just estimations looking at the graph. Estimations. Now, if you're going to prove it, so we estimated at negative 0.5 for the max, well, do some values around there. So, negative 0.5. And look at the value. The highest point it hits is 0.125. So I didn't estimate 0.5 correct. It was 0.125 if you prove it algebraically or numerically. But I plug it in. So the actual max is negative 0.5 and 1.25. So that's why we prove numerically, to make sure we understand the exact value. You can do the same thing for the min. You just plug in 1. If I plug in 1, I get negative 1. Alright, so what I want to do is show you on the graphing calculator how to find the relative and max, because in calculus you have to have precise values. So instead of just plugging it in, the calculator will give you the precise value, even though you can estimate it. So, okay, so graph. And we said the function, we're using the exact same function, f of x equals x to the third minus x squared minus x. So, x to the third minus x squared. Oops, I didn't finish it up. Minus x. so here it is, the exact same graph on the other one. So what you do to get the relative max and the relative min, menu, analyze, we're going to do max first. Click on the left, click on the right, and there's the max. Did I put the right one? So actually, click on the left, click on the right, and then you get the graph. So if we actually look at it now, it gets even more interesting. We estimated it at -5, okay, -0.5, and I estimated it's about halfway through also, so about halfway up. When we kind of put those our estimations in, well, the -0.5 is actually 0.125, so that's the numerically. Now to get the precise value, the calculator got the precise. So that value is actually -0.3333 and 0.185. So it actually changes the whole thing. Precise value. So there's estimation numerically, and then there's your precise. Now let's do the minimum. Now we estimated the minimum to be -1 and 1. That one looked a lot easier to see. So analyze, minimum, left, right. And we actually estimated that one okay. If we would have plugged a 1 in, we would have got -1. So we did good on that one. But again, we are human. We can't see a graph perfectly aligned. So the graphing calculator will give us the exact value at the relative max and the relative min. Now again, it did not have an absolute max or absolute min because it continued on. Alright. So this assignment was page 40, 2 through 30 even. I'm okay with you not proving it numerically. You can do the estimations, but then use the graphing calculator to prove it exactly. If you don't see this video, then you don't see me saying that, then you're going to be doing a lot more work than you have to.